Hello and welcome to another of the Richardson lectures on the challenge of resource management. This time we'll be talking about increasing food supply. It's important we can explain the strategies used to increase food supply, but also to consider the limitations of some of those strategies. Now, first of all, something important to make clear. This video is going to focus on strategies used to increase food production. There will be a later video that talks about sustainable food practices, sustainable food production techniques. It's important you know the difference because in the exam, the specific questions will require either sustainable food production techniques or not. So it's important you know what you are answering in the exam and what techniques to talk about. Now, the strategies explained in this video will increase food production but not strictly be sustainable. So that's why we shouldn't be getting confused between the two groups. So, our first strategy is irrigation. Now, irrigation involves artificially watering the land. It's used to water dry areas of land. And it usually involves using water either pumped directly from rivers or from aquifers. So, aquifers are rocks that can store water. They're porous, they've got spaces between the grains that make up the rock which allow water to sit in, and we can drill wells into those rocks and draw the water up. Now, it's great for allowing food production to take place in very dry areas, so immediately that's going to increase food supply. So as an example up here in the top right of a desert area, obviously no vegetation growing there because it's so dry. However, we've got these big green circles and these are crops growing, and that's because water's being pumped, likely to be from an underground source, pumped to the surface and then sprayed over the land using something like this. In this case it's going on a pivot and it's moving around in a circle to ensure the land is well watered and allow crops to grow there. So irrigation can involve many different techniques really, but it can involve either spraying the land with water, something you may even do at home in your own garden in dry periods of time, or involve something more sophisticated like this drip technique where pipes and tubes are moved around in a crop field with little areas for water to drip out of. And so it reduces the amount of water being used and ensures that it's directly given to the plants that need it. Some very sophisticated irrigation techniques can help to monitor the fields and ensure water is distributed where it is needed most. Now, there are some limitations to irrigation, the main one being that obviously a lot of water can be wasted. If you're spraying the water in a very dry area, lots of evaporation is going to mean that a lot of that water is going to be lost. Obviously in dry areas, water is also needed to drink, and as a result there's a conflict of interest about food production versus water for human consumption. And in those dry areas, if water has been taken from aquifers faster than the water is recharged, that is the aquifer being refilled, the water is going to run out. So these aquifers are not, that would be unsustainable. These aquifers are not going to have water in them forever in a lot of areas if we're using the water faster than it's been able to refill, to recharge. Now the next one is aeroponics and hydroponics. These two are very similar. They're a very high-tech method of food production that doesn't require a soil. Now, plants need soil to grow because that's where they're getting their nutrients from, but these techniques have mastered the ability to grow plants without soil. They get the nutrients in other ways. It's often also indoors and uses artificial light. Now, the benefit of using artificial light is that crop yields can be increased because you can have your food production all year round. Obviously, in a northern latitude like the UK, food production is limited in the winter months because of the long dark nights. We have very short days, so sunlight is reduced. So using artificial light, you can grow crops 24/7 all year round. So significantly increasing food production, and also by growing them indoors, as you can see in this top image here, we can actually grow crops in layers. So a relatively small area, if we're vertically farming, means we can grow a lot of food in a relatively small space, which of course is fantastic. Now, the difference between the two, hydroponics involves the plants being grown in a mineral-rich water. So this top right image is showing some hydroponics. The plant is growing, the roots, should I say, are growing into this nutrient-rich water, which is enriching the plant. Aeroponics involves using less water because that involves the plant roots that are exposed just being sprayed with a fine water mist containing the right amount of nutrients. So that one's possibly arguably better because of the fact that it uses even less water. But of course there are some limitations. It's a very expensive type of food production. The cost of heating and lighting is going to be very high, and as a result, for many low-income countries, these techniques are going to be too expensive. And it's those low-income countries which we know have the biggest challenges of food insecurity and need their food supplies increasing the quickest. And some people also think that the food grown this way doesn't taste quite as good. It hasn't got that kind of earthy taste as you would get if it had been grown on the land. Now the next one is a kind of a group of strategies that comes under the umbrella called the New Green Revolution. It's called the New because there was an original Green Revolution during the 50s and 60s, and this is a period of time where we saw agricultural yields dramatically increase due to a result of new farming technology and farming techniques. So it included the use of machinery, so moving on to using machinery meaning less human power was needed on the farms, and land could be tended to in a much more efficient way. Also breeding more high yield varieties of crops and even breeding that into livestock as well. Using a lot of chemical fertilisers on the land and pesticides to kill off pests to again drive up those yields, and also new methods of irrigation. So the New Green Revolution is something that a group of techniques that have come out in more recent times, from 2006 really, and mainly in India where this started, to help to increase food production, because we know there's a need to increase food production because of the huge amounts of food insecurity around the world. So some of these techniques include things like water harvesting, so collecting rainwater and storing rainwater, now understanding how important the soil is, so protecting our soils to try and reduce erosion, and also using things like biotechnology, which I'll be talking more about in a moment. Now, again, similar to the kind of one of the main limitations of hydroponics and aeroponics, the New Green Revolution is very expensive. A lot of these techniques are still quite expensive, and so for the individual farmers, small-scale farmers in low-income countries, these techniques still might be too expensive for them to access. Now, the next one is biotechnology, or more specifically genetic modification. Now, that involves changing the genetic code of plants and even animals to get a more desirable outcome from that food source. So changes that can be made could be to encourage a faster growth, larger yield, so a larger crop, and also disease resistance. So you can massively increase your yields by genetically modifying plants and animals to be more adapted to a particular environment. So something could become more drought resistant strains of crops so they can grow in particularly dry areas. It will also, another benefit of this is it will reduce the need for using chemicals. So instead of spraying the land with fertiliser, the crops can grow well without fertiliser, or if they're struggling from a particular disease and we have to spray chemicals on to perhaps kill pests that transfer in the disease, but if they're genetically modified to be disease resistant, then we don't need to use those chemicals. However, there is a lot of opposition to this, potentially because of the unknown human health impacts that eating GM foods could have, and also the moral argument about genetically changing plants and animals. Now, personally, I see that we've actually been doing this for actually thousands of years through the domestication of plants and animals. And GM production is actually just speeding up this process. When we domesticate animals, for example, if you take cows and we want to increase the milk yield of dairy cows, we would choose the cows that produce the most milk to breed, and those that perhaps have smaller milk yields we wouldn't allow to breed, so that you're passing on those genes. That's something we've been doing for thousands of years. That's how we've got the strains of crops and many of the domesticated farm animals we see today through that process of domestication. And I see that all GM's doing is speeding up that process. Once we know the genes we want, i.e. for a crop to be resistant to drought, if we can embed that into that crop genetically, then it's kind of speeding up that process. And finally, appropriate technology. Now, This involves using cheap techniques to improve food supply, but also that won't put people out of work. We find that in many high-income countries, actually many people today don't actually work in agriculture. Even on these huge farms, very few people actually work there because machines can do most of the work. But we don't want to put people out of work, particularly in low-income countries. So often small-scale techniques such as new small irrigation techniques, there's a lady here using a small well, but also perhaps some new water harvesting techniques, storing water. So they're aimed at people living in low-income countries. Techniques can just help them to gradually increase their food supply. Of course, the main limitation of that, though, is that because they're so small in scale, they do actually have a limited impact on actually increasing food production. Right, so we'll just finish off by looking at an exam question, rather straightforward one here. It says, explain strategies used to increase food supply, 6 marks. The food resource section of the exam paper usually ends with a 6 marker. Many of these often ask you to refer to an example. We haven't looked at those yet, so here would just be an example of a purely knowledge-based question for 6 marks. And really what you'll be looking at for 6 marks is 2 or 3 explained strategies. If you're only going to do 2, they need to be very well explained strategies of how we can increase food supply. So by naming them, you're going to pick marks up, and then explaining them to get more marks. And any of the strategies we've talked about in this video, you could use in this question. So that is irrigation, hydroponics and aeroponics, the new green revolution, biotechnology or GM foods, but also appropriate technology. So naming them and explaining those strategies for a pure knowledge-based question like this will get you the marks. Okay, so that's it for this video. Next time we'll be looking at a specific example of a increasing food supply strategy.